Hello everybody. So we're going to be starting a new unit on functions. So I really wanted to introduce the whole idea of functions using function tables, and that's what this video is going to be about. Well, first of all, what is a function? A function is a rule that gives us a specific output, which is usually listed as y, when we use a specific input, which is usually x. Y is sometimes going to be referred to as f of x instead. Either way, it's still what we get when we've done math to x. A function table is a nice way of organizing our inputs and our outputs and showing what happens to get from input to output. An analogy I like to use to describe functions and how they work is just think of a machine or think of a factory. All right, so like think of a car parts factory. Steel comes into a car parts factory unprocessed. I mean, it's been refined, but it hasn't been shaped into anything yet. So the steel comes into a car parts factory and it's cut, it is shaped, it is pounded, it's it's worked on by everybody in the factory, and then it comes out as a car part. So the steel is the input. All the work that the factory workers do to it is the function itself, and then the car part is the output. All right, so that's what we have here. So this is a good example of a function table. We have our x, which is our input. We have our function, which in this case is that y equals 2x plus 1, and we have our output, which is y. So what we do is we take our input and we replace the x in the function with whatever number it is. We complete the math and we get our output. So if our input is 1, our function becomes y equals 2 times 1 plus 1. And in that case, the answer would be 3. Okay, if our input is 2, then our function becomes y equals 2 times 2 plus 1. And in that case, the answer would be 5. If our input is 3, then our function becomes y equals 2 times 3 plus 1. And in that case, the answer is 7. If our input is 4, then the function becomes y equals 2 times 4 plus 1. And the answer is 9. All right, let's practice some more with some tables. All right, in this table, the function is y equals negative 7 times x. And we are given a collection of x's here. 1, 2, 3, 4, and 5. I feel like it's always best whenever you have the choice of choosing x's, it's always best to work low. Work with simple numbers. You'll get some reasonable y's as answers most of the time. So let's just work with what we have here. So if our input is 1, we start by rewriting our function. So in this case, y will equal negative 7 times 1. The answer, of course, is negative 7. If our x is 2, then our work becomes y equals negative 7 times 2. And the answer is negative 14. If our x is 3, then our function becomes y equals negative 7 times 3. And our answer is negative 21. If our input is 4, then our work becomes y equals negative 7 times 4. And our answer is negative 28. And if our input is 5, then our work becomes y equals negative 7 times 5. And our answer is negative 35. Okay. Pretty good. Over here with this table, we are given a column for our input. We are given the function y equals x plus 4, and we're given a column for our output. We're not given anything else. So in this case, it would be up to us to choose our inputs. So we can really choose any numbers we wish. All right, I might want to go with inputs 1, 5, 9, 11, and 22. It doesn't have to be 1, 2, 3, 4, 5. It doesn't even have to be in order from least to greatest. I could jump around. My function is going to work no matter what. So, okay, let's plug and go. So y will equal, for if our input is 1, our function will be y equals 1 plus 4. So our output will be 5. If our input is 5, our function will be y equals 5 plus 4. And our output will be 9. If our input is 9, our function will be y equals 9 plus 4, and that'll equal 13. If our input is 11, our function will be y equals 11 plus 4, and our output will be 15. If our input is 22, our function will be y equals 22 plus 4, and our output will be 26. All right? This is a basic overview of functions and function tables. It will get harder later. Thank you for joining me, though.